Hello there. Topic 2 now. This is the moon, and we're going to go through the first 5 parts of the topic. So 2.1, 2.2, 2.3, 2.4 and 2.5. So more specifically, I'm going to go through here. So this is the topic can be called the lunar disk. So we're going to look at the shape of the moon. I mean, this is pretty brief, really. If we've looked at the shape of the Earth, the moon is very similar. And then those are the key terms that we'll need to understand and need to be able to point out on the moon. So, this, if you download the PowerPoint from Class Charts, this is a phrase that the people could use, lemon-shaped moon. But essentially, the moon is not a perfect sphere. So you just need to understand, in the same way the Earth is not a perfect sphere, the moon is exactly the same. It's an oblate spheroid, so it bulges around the middle. Like you learnt, the Earth bulges around its equator. So this has the same bulge. And when it was formed, it was spinning molten rock. So in that liquid form, the spinning has made it bulge around the edges when it wasn't solid rock, and still to this day it's that shape. There is more to it, I suppose, and it's not a perfect oblate spheroid, but that's the shape that we use. So if you look into more detail, then you are going beyond what the course wants you to know, I suppose, whereas the perfect answer in the exam would just be an oblate spheroid. And I think the questions I've seen, they're asking you in multi-choice, what shape is the moon? Okay, so you can watch that video. And then we'll get the idea of a few misconceptions now. So there we go. So this one looks more like you'll see in textbooks, and the reality of it is probably this. There's another misconception here as well, that they're both perfectly lit, and textbooks very rarely show part of it in darkness. And of course, at any one time, only half of the Earth is lit and half of the moon is lit. That's the half facing the sun. Okay, so there's some exact values of the Earth's diameter, the moon's diameter, and the distance from the Earth to the moon. But a quick bit of maths would work out a simple ratio there. Okay, so here's another image of the scale of it. But that's about 30 Earth diameters. So probably, on the grand scheme of things, and some of the distances that we're going to learn about, that's pretty close. You could get to the moon in 3 days, I would think. To get to Mars is about 7 months. Venus is closer, and with some of the planets, you're going to go to the planets, you've got to swing via the sun. But yeah, Venus would probably be about 5 months. So just a few days to the moon. So it's pretty close. There we go. So while these are the exact values, the values quoted on the course are, you just need to know that the Earth is about 13,000 kilometers in diameter, and the moon is about 3,500 kilometers in diameter. But these are values that we don't stress about. You would probably note it down, but you're not trying to memorize at this early stage in the course. We'll just look at all the values that you have to use later on. And this is a nice little task that you could try. So if you knew one of the two, diameter or distance, so if you knew the distance to the moon, then you could stand there, use a little piece of kit to get an angle. You could put a protractor on a piece of paper. You could do this quite easily. And if you work out the angle, then you could use a simple bit of trigonometry to work out the diameter of the moon. And that's, of course, once they got one, it was easy to get the other one. Okay, so here is the moon we know and love. It's a pretty spectacular thing, really, if you've never looked at the moon in detail. And it really does come to life with just a simple pair of binoculars. It's a funny thing about the moon, if you're on a different part of the Earth, it will look upside down. So, if you look at an image of the moon from Australia, South Africa, it will appear upside down. So this huge crater at the bottom with all these blast lines, this Tycho crater, and that will appear on the top if you're in the southern hemisphere. And you just simply explain it by the fact that we're upside down. We're looking at the same thing in the same position, but we're the other way around when you're in the southern hemisphere. But yeah, so that's, everyone will see this face, but it could be twisted around, rotated around. So what's that? And that is the far side of the moon. So that's the side we never see. There's a huge feature right in the middle there, but we'll talk about the far side of the moon another time. So what's the difference between the two? I suppose here you can see that these dark patches, which we'll talk about, there's quite a few of those dark patches, and here not so many. And then the dark patches probably don't, they seem very smooth, so you can't really see many craters on the dark patches, and here there's just craters everywhere. Okay, so the far side has more craters and fewer what we call seas or maria, which I'll get to in a second. Okay, now this is a video that you can watch when you download the PowerPoint, and it's just an images of the far side. You know, we saw the far side a long time after we saw the near side, obvious reasons. This is the dark side of the moon, and that is the only image associated with the dark side of the moon. So at any one time, half of the moon is in darkness, half of the moon is in light. When we can see a full moon, it is true that the far side of the moon is currently the dark side, but when we see a new moon, then it's the near side of the moon that's the dark side. There's a dark side of the earth. At any one time, half of the earth is lit, half of the earth is in darkness. So whichever half is in darkness is the dark side of the earth. But it's not a phrase that we would use in astronomy, but we would use far side of the moon, which is the side that's always facing away from us. So that's because of something different. Sorry, that's because of what we call synchronous rotation, which we'll get to at another time. But synchronous rotation basically means it takes the same time to rotate as it does to orbit the Earth. Now, rather than me spending too long on this video, that is something that is very, very easy to show in class with a little model of the moon and a little model of the Earth. So that's what we'll do. But it's very special, it just never turns its back on us. So this is the side that we're always facing, and the key features are the dark patches called maria or seas. And you maybe can figure out why they're called seas. They look like seas. They look like just vast expanses of water. Now, water couldn't exist on the surface of the moon. It would be vaporized by the sun's rays, but we thought a long time ago that they were seas. So they're very smooth. It's basalt rock. It's formed by cooled lava, which has come from volcanic eruptions, and it's smooth, shiny rock, which is why it looks so dark. Yes, it's dark rock, but it's because it's so smooth, it doesn't scatter the light into our eyes, so it appears dark. And then the areas that are not covered with the lava, we would call the highlands or the terra. So, you know, when the volcanoes erupt, the lava comes out, and naturally it will just fill in the lower ground, those lower areas. So you can see the amount of volcanic activity that took place. So this would be, because it's not hit by as many craters, you would say the maria is evidence that it's newer. So, okay, so we've got the highlands and the maria. So, some famous craters. The moon is absolutely covered in craters. It's got no atmosphere, the moon, so there's no change, there's no erosion, there's no weathering, there's nothing growing over these craters. So the Earth has a huge amount of craters that you can no longer see anymore. They're underground, they've been covered over. But on the moon, it's just, all the scars are there to see. So some of the most famous craters, Copernicus, these are huge things. And if you look closely, you know, if you look through binoculars, they're great to look at. They really are, to see the detail of the shadowing. Tycho crater, probably the most famous. If I look at the moon over here, you can see this is Tycho crater here. And it's very, very obvious because of the huge blast lines that just go all the way across. Okay, and that's one of the best ones to watch. And to be honest, even though a full moon is spectacular, if you were observing the moon, it's much better to observe at times when the terminator line, that's the line between the light and dark, is closer to the thing you're observing, because then you can see the shadowing more and you can tell more of the features of it. Okay, so there's a Tycho crater. It's got mountains on the moon, so this is one of the biggest, and it's, you know, the biggest mountains on the moon are about half the height of Everest, so they're very sizable mountains. It doesn't look that big on this picture, does it? It looks like a little hill, but yeah, they get pretty massive. So it's lots of highs and lows on the moon. This is an interesting point on the moon, Mare Imbrium. which is a huge. I mean, you can see the shape of the moon, hopefully, so you can figure out what size this is, and you can go back on the previous photos and have a look at it. But Mare Imbrium is this thing all the way around here, and it's one of the largest collisions in the solar system. We think it was hit by something so big that it would be defined as a protoplanet, not just a little asteroid. Absolutely huge. And since then there's been other impacts you can see, which are the craters within a crater, I suppose. But that's a really interesting point, but not something that you have to memorize. Here's one of them that you have to memorize. So right around the Mare Imbrium is the Apennine mountain range. So this is by far the biggest mountain range on the moon. And again, you can see, because you can see this terminator line, which is the darkness coming in here, you really get the nice shadowing there, which reveals some of the features. And there's Copernicus crater, which is one of the craters you will need to be able to pick out. Okay, now on the list, if you look back at the list of things you need to know about, they talked about valleys. So these would be lower areas, and they will be summed up with ridges and riles. So ridges are to do with the volcanic activity that's took place. So as the lava's come up and it's cooled into rock, it's contracted. Very often when things cool down, they contract, they shrink a little bit. So as it shrinks, it leaves lines, cracked lines in it, and that's what we think wrinkled ridges are. Okay, so the other type of valley, as well as a ridge, here's some lovely look, looks a bit like a lizard or something, the ridges there. And the other type of valley would be the riles. So the riles are thought to be collapsed lava tubes. So the lava was underneath the ground and it's made this tube, and it's all collapsed within itself. So those are the riles. So yeah, you'd probably just note down that the ridges are to do with contracting lava as it's cooled, and the riles are to do with collapsed lava tubes. And that's all. It wouldn't be worth more than a mark or two in the exam just to know the difference between those two. But if we're being totally honest, who's going to read this and remember in a year and a half time what the difference between a ridge and a rile is? So don't write too much, just a very basic notes, and it's something you can go over and just test yourself in the few months preparing for the exam. But these are the valleys, what they'd call valleys on the moon. Okay, and this is the largest one, which is a composite of different images. There we go, so there's some more riles and some more types of riles. And you do not need to know the different types of riles. Alright, and this is evidence of them, the same features existing. You can see them on Mars and Venus here, and Europa, which is one of the 4 Galilean moons, the famous moons of Jupiter. Jupiter has more than 4 moons, but they're the 4 ones Galileo saw with his telescope. One of them, sorry. Okay, so that's it for some of the features. And what you need to know, if I race back just to the start here, and you'll need to know these 7 parts of the moon. So you can read them for yourself, but Tycho is a crater, and Copernicus and Kepler, they're craters. So there's 3 craters, 1 mountain range, and then 3 of the Marias. So I know 2 are called a sea, 1's called an ocean. The Sea of Tranquility is really famous because of the moon landings, but those 7 images, you would get a picture of the moon in the exam. It would point to one of these things, and it would give you a multi-choice out of 4, and you'd have to say which one it was. So I'll leave that to you. Just draw a diagram. There'll be a homework attached to this which will ask you to point at them, and you can use that and stick that in your book if you want, or you can just draw a lovely diagram which points out those 7 features. If you are drawing a diagram of the moon, I would just label those 7 things on, because you won't be asked to point out any other things. You could be asked what is a Maria, what is Terra or mountains or valleys, but you won't be asked to point them out on the moon. So I would say a nice little diagram showing A to G from 2.5 there. Okay, there'll be another worksheet to do as well, so I just wanted to be brief here because it was just showing you the images. You could have researched this all yourself, but I've kind of done the job for you getting these images. Okay, I'll leave it there. Thank you very much.